So up to the last class, anyone having any doubt, any confusion that you want to clarify? So I hope all of you have understood up the things up to the last class, right? Just let me know. So all those nomenclature, etc., those things already we have discussed in the last class. Okay, there we have discussed also about the law of gearing. From there, we have seen that along the common normal, we don't want any movement. Okay, any relative motion between the two meeting gear teeth, and we have seen that sliding velocity is actually expected along the common tangent. Okay, and later on, we have also found out the expression for sliding velocity, finding out the sliding or velocity of sliding or sliding velocity and all. Okay, and also all those nomenclature, different nomenclature with respect to gear, different terminologies, those things we have discussed. Also we have discussed about the backlash, what is the backlash, what are the problems if there is excessive backlash and all. Okay, we already know about all those module, etc., all those different terms which we already know. Okay, and also we know about the different expression that is there. Okay, m equal to d by t, etc., etc. So if you don't have any question, we'll move ahead. Just let me know someone. Shall we move on? Or shall we wait for some more minutes for others to join? Or shall we start? Okay, since I'm not getting any response, so I'm considering you don't have any question and we'll move ahead. Okay, so now today we'll be discussing about the forms of treat. Okay, in case of gears. So by this previous knowledge, from our previous knowledge, we already know that the gears. Okay, so the whenever we are saying that the two gears are in mesh, suppose gear A and gear 2, suppose gear A being the driver and gear B being the suppose driven gear. Okay, then we know that basically we talk about like the meshing of the gears, and in that particular case we know actually the teeth from both the mating gears, they are actually in contact somehow. Okay, so the and through that particular contact of the gradual contact of this particular teeth and all. Okay, the by proper meshing, so actually in the through that only actually the all the force transmission, etc., or the torque transmission that is happening, and ultimately we are getting the movement in the driven side. Okay, as per whatever is the velocity ratio of that particular drive. So in that particular case, so we know that teeth is very important. Okay, because the teeth are actually messing. Okay, that is they are engaged with one another, and if they are not there, then basically particular engage or respect to the because they are not in mass, so it is of no use. So the drive has to be in proper mass and all. Okay, so in that case, these forms of the teeth, that means the design or the look of the teeth, that basically is important. So now if we want that there should be proper meshing, which is very a vital requirement. So for proper meshing as well as for proper motion transfer, the shape of one teeth you can choose arbitrarily. Okay, and you can design the shape of the other teeth, okay, in such a way that both of them follow the law of correct gearing. So in the previous class we have discussed about law of gearing, and we know that whenever we follow if a particular pair of gear teeth, okay, from driver and the driven, if they follow the law of gearing, then we can expect that there will be proper constant velocity ratio and all, and the drive will work properly. That gear drive will work properly. So in that case, what we are the main possibilities, like you can, like if you are thinking that you have to suppose engage two suppose gears. Okay, so in that particular case you want to for your profile you can like design arbitrarily or choose arbitrarily, and next while you're going to choose the meshing gears, okay, the teeth profile for the other gear which should be in mesh with this. So in that particular case you have to take care properly, and if you are able to design the teeth or the form of the teeth in such a way that they actually follow the law of gearing, correct gearing, then that particular pair of gear it will work. And this kind of teeth are called as conjugate teeth. Okay, conjugate to each other, that means one of the teeth profile it meshes with the properly meshes with the another teeth profile. Okay, so they that particular pair, that means it works properly. So that kind of forms, they are the teeth are known as the conjugate teeth. But What is the problem with that? So see, if we each and every time if you choose something arbitrarily, some design parameter if you choose arbitrarily, and based on that particular whatever chosen profile you have, if you keep on working in the backward direction and backward direction and all, so that the other pair of teeth, the teeth profile of the other gear, if it has to follow the proper law of gearing and all, so in that particular case it becomes very tiresome to manufacture, and like specialized device also will be required. One thing is to design that conjugative properly will be difficult, because if you like keep on making it arbitrary, okay, suppose if you keep on changing the parameters and all, and based on the new parameters suppose you require the other pair of teeth and all, okay, so in that case it becomes difficult, okay, difficult to design as well as difficult to manufacture, because for gear design, gear manufacturing, you know that some of the gear manufacturing method you already know in the workshop also. You, I believe you have cut gear with the help of the indexing and those milling and all, okay, so there are specialist devices, all those standard devices and standard ways and means, these are already there to manufacture gear, manufacture the standard gears. And if you come up with suppose some arbitrary design and all, which may work if it is conjugate teeth, it will work, okay, but manufacturing it will be difficult, okay, because the design itself is somewhat different, and for that, for doing that kind of manufacturing, suppose you don't have a specialized tool, okay, so that is the difference. And that's why some of the common standard form of stage which self satisfies the law of bearings, okay, so that kind of specialized standard teeth or common teeth, we teeth profile we go for. And what are the like the form of streets, the common standard form of forms of teeth which also satisfies the law of gearings, and which for which the manufacturing method we have already established manufacturing method, okay, so these are basically two types of forms of teeth basically we have standard teeth profile. So one is the cycloidal teeth profile, and another one is the involute teeth profile. So in case of psych, I believe from your engineering mechanics knowledge, engineering drawing knowledge, you already know, you have drawn cycloid, you have drawn involute and all. So basically the profile of the, or the look of the teeth of it, okay, it will be part of a involute if it is involute teeth profile, and it will be kind of part of a cycloid if it is cycloidal teeth profile. So if you can recall what is involute or what is cycloid, so basically cycloid, what was cycloid? It is the locus of a point on the circumference of a circle, which rolls without slipping on a fixed straight line. So all of you, I believe, already have drawn cycloid in your engineering drawing. Similarly, involute, what is involute? How we can define it? Involute is nothing but on the circumference of circle. So now you are understanding it, okay? So I believe I believe you have heard about this particular type of cycloids, involutes, and all in your engineering graphics. And if you have forgotten, maybe you can just go through it. So these are the standard forms of teeth actually that we have. And in case of cycloid tooth profile, so generally the face portion of the teeth, it is the epicycloid, and the flank portion, the below portion, lower portion, it is the hypocycloid. And in case of involute, okay, so what is the like ease, okay, what is the why we go for the generally involute teeth profile? So because see, so if even though we know that both of these particular two choices we have, that is cycloid tooth profile we can also have involute tooth profile. Both of them are kind of standard forms of it, as well as they satisfies the law of gearing. So the satisfaction of laws of gearing, that is what is our prime concern. If the a particular pair of teeth, if they follows the laws of gearing, then I can say that they will be in proper mass, and we can work that particular profile for doing a particular job, okay. So now in the case of involute teeth profile, generally we already have the ease of standardization in manufacturing, and because of that the cost of production, it goes down. So it is, that's why some nowadays it is kind of the better switch that we have, okay. And so that is basically about the different forms of teeth. So what are the two standard form of teeth we generally have? The cycloidal teeth profile we have, and the involute tooth profile that we have. Out of these two, we generally better choice is the involute tooth profile. Why? Because we already have ease of standardization as well as manufacturing, okay, and it lowers the cost of production. So these are the two main reasons why we generally involute tweet profile are even preferred over cycloided tweet profile also. Okay, so you can just go through involute as well as cycloided tweet profile in some more details. Maybe if you follow any books and all, you'll get about it. Okay, so how can define and all. Okay, and similarly we have some interchangeability of gears. So what is the interchangeability of gears or interchangeable gears? So basically in the word itself the interchangeable is there. Okay, you can change or with one with the other, and we'll get the similar kind of effect. So that is nothing but the interchangeability or interchangeable gear. And when you can when what are the factors that affects the interchangeability of gears, so those things also we can go through, and towards the end we'll also discuss also. And similarly we can have non-standard gears now. Okay, so it can be done. So that's if you follow any book, okay, you will get about it. Okay, so next, up to this much, I hope all of you have understood why what that means we can have different forms of teeth and what are the standard forms of teeth. Why what is conjugate? What we mean by conjugate pair of teeth and all. Yes, someone may please let me know. Yes or no? You have understood, right? Hello, am I audible? Okay, thank you. So now, as we know that basically the teeth from the boom meshing gas they are in contact, and the contact is made gradually. So by this time already we know all the teeth from both the gas they are not in mesh, or they don't come in contact with one another at the same time. Okay, so we have a certain number of pair of teeth which are in contact at a particular time of life, as well as we have, if we consider a particular pair of teeth, okay, then we have a certain length, okay, over which a particular pair of teeth are in contact. And as we know that contact is gradual in case of all those gears and all. Okay, so they comes the teeth of the two meshing gears, they comes in gradual contact with each other. That means somewhere the contact will be made, and after some time somewhere the contact will be broken, and that particular somewhere has got some name, and those are the we have got the words like names like path of contact. And now within that path of contact, once again we have two portions of that particular path of contact, which makes addition of which basically makes the path of contact. So one, we have the path of displaying here. So okay, so if you look at the ZF, that is animation that you can see here. So how can define the contact? So basically the contact of the two teeth, okay, two meshing teeth that we are talking about, that is one from the driver, one from the driven. Okay, so suppose left side is the driver, right side suppose is the driven and all. Okay, so now the contact of two teeth is made when basically the contact is made when where the addendum circle of the driven wheel it meets the line of action whenever it is happening. So actually the contact is made. Okay, so what is the line of action? You know that line of action is nothing but the common tangent to the base circle, okay, or the addendum circle sometimes. Okay, if they are same. So this blue line is nothing but the common tangent to the base circles, that is nothing but the line of action. So where the contact is made, so you know, if suppose this is the driven, so here the addendum, okay, so whenever the addendum, this is the addendum circle, we know the from the uppermost portion. So for both the meeting gears, we have got two addendum circles. One is this one, and another this one. Okay, so whenever the addendum circle of the wheel it meets the line of action, so actually here you'll see dot one dot will be shown. Okay, so here actually the contact is made. Okay, and when it is broken, and it is broken where the addendum circle of the driver, that is the pinion, okay, it meets the line of action. Okay, so now if you consider this wheel, the right wheel, okay, right side wheel, which means the gear only we are talking about, and this particular line of action, so whenever actually the addendum circle from the right hand side gear it meets the comes in contact with the line of action, there the contact is made. And whenever, if you consider the left hand side gear, and if you consider once again this particular line of action only, and whenever it is this from this particular gear, left gear, whenever the addendum circle it meets this particular the addendum circle of this particular wheel meets the part this line of action, okay, the blue line, then the contact is broken. You can see that particular. So so the cursor will see from where it starts and here it ends. Okay, so this linear distance actually between these 2 points is known as the path of contact. So this path of contact is the linear distance, and it has got two portions that we have said. So path of approach, it is the portion of the teeth path of contact from the beginning of engagement to the pitch point, that is half of it. So up to this much, this is basically is the path of approach, and next half actually is the part of races that we have. Okay, actually it may not be the total exact half, but two different portions. Okay, so part of races is nothing but the portion of the path of contact from the pitch point to the end of engagement. Okay, so from starting to the pitch point, that is part of approach. From part of approach to the end of engagement, that is part of races. Okay, and if you add them two up, you are going to get the total path of contact. So now we have got different expression for path of contact. So you can just go through any book and you can find the expression for path of contact, which is a summation of path of approach plus path of races. Similarly, we have some other terminologies like arc of contact, angle of action, pitch angle, etc. So what is arc of contact? So now during that particular part of contact, I already have seen that animation and all. So now arc of contact is, it is the distance traveled by a point which is either which on any of the pitch circle. Okay, you can consider from the pinion or you can consider from the driven. Okay, on either the pitch circle of the two wheels during the period of contact of a pair of teeth. Okay, so it is that particular distance, okay, which is on which distance traveled by a point which is on the on any one of that particular pitch circle. Okay, during the period of contact of a pair of teeth. So how we can get the arc of contact? So if you have path of contact, if you know the path of contact, if you divide it by cos of the pressure angle, cos of phi, phi is here is the pressure angle, so you get the arc of contact. So for finding out path of arc of contact, that means knowledge of path of contact as well as the knowledge of the what is the value of the standard value of this particular pressure angle for this particular gear. So that will be important. So similarly here also, in the case of arc of contact also, two portions are there: arc of approach, arc of recess, just like the path of approach, path of recess. Okay, you can go through it. Next we have angle of action, how it can be denoted. So both of these are with respect to the this figure is denoted by the, okay. So it here from the beginning of engagement to the end of engagement for a particular pair of teeth. Okay, so during that engagement, am I audible now properly? Hello, I am audible. Okay, thank you, Tapas. So now angle of action is during that particular starting of engagement to the end of engagement of a particular pair of teeth. So the wheels are rotating, right? The gears are rotating. So during that rotation, during that time, it will rotate by a particular angle, and that angle is known as the angle of action. And once again, it is just like the previous cases. We have got the angle of approach and angle of recess, and if we add them two up, we get the total angle of action. Okay, so this particular angle will have different values for the driving and the driven gear, because for within a particular time, depending on what is the velocity ratio of this particular drive, both the driven and driving gear will rotate by some different angle, and during, if that is happening, that means the angle of rotation will be also different. Okay, so angle of action, it is different for both the wheels. And similarly we have got pitch angle. So what is the pitch angle? We can consider this as the angle subtended by the circular pitch at the center of the pitch circle. Okay, so next, as we are saying that all the teeth of the from both the gears, they are not they don't come in contact at the same time. Okay, there is a, if you look from the previous diagrams and previous emission. So actually a particular pair, okay, or some portion of this particular pair, maybe and some other portion from suppose another pair and all, okay. So only a limited portion of teeth they comes in contact, okay. And that means the knowledge of number of pairs of teeth which are in contact at a particular time, so that will be important. And actually that is known as the contact ratio, okay. And how we can get the contact ratio? So contact ratio, so if we have to like get the contact ratio numerically, then how we can get it is the angle of action divided by the pitch angle. That is how, if you know about both the angles, you can get contact ratio is generally denoted by n. So it is delta by gamma, okay. So already we have discussed about both the things. So that is one way. Next, once again, the number of teeth which are in contact, which is nothing but once again gives you the indication about the contact ratio. It can also be obtained by dividing arc of contact by the circular pitch, which is one of the most common way of finding out the number of teeth which are in contact. Okay, so small n. So arc of contact, as we have previously discussed, arc of contact can be obtained by part of contact divided by cos of phi, that is the cos of your pressure angle. Okay, and circular pitch we already know, p suffix c, it is given by pi d by t. So where d is the pitch circle diameter we are talking about, t is the number of teeth, and d by t, that gives you nothing but the module. Okay, so we can write pi m, module is m. Okay, so we can write, so how we can find out the number of teeth in contact by this particular formula. Path of contact divided by cos pi, which gives you the arc of contact multiplied by 1 by pi m. Okay, or you can say that divided by circular pitch, that is circular pitch is nothing but pi m. So divided by circular pitch means which is 1 by pi m. Okay, so now the all the teeth lying in between the arc of contact, okay, actually will be messing with the teeth on the other way. So whatever previously we have discussed as the arc of contact and all, so within the arc of contact too, whatever number of teeth they comes within the range of this arc of contact, okay, which are lying in between the arc of contact, actually they will be meshed with the teeth from the other way, okay, and rest will be like they will not be in contact. Okay, and if we are talking about this contact ratio, now we want that both the squeeze actually, like we have to have a continuous transmission of motion, right? So if that has to happen, which is a desired and very essential form only, it has to, we have to have continuous transmission of motion. So in that case, the value of n, that is the number of teeth which are in contact, will be pair of teeth which are in contact. Okay, so that way it has to be after this. Yes, I hope you have understood. Now, as I was
Yes,
saying that
sir.
n has to be greater. Okay, thank you. So as we are saying that n has to be greater than 1. Suppose n is greater than 1 and it lies within 2. That means 1, like n lies between 1 and 2. Okay. So then what is the meaning of it? So then the meaning is, that means the number of teeth in contact at any time will not be less than 1, and it is not more than 2. That will be the meaning of n lying between 1 and 2. So 1 less than n less than 2, if it is written like that, then that means the number of teeth in contact at any time, if you consider any instant, any time, then it will be always more than 1, but not more than
Visible.
2. So yes, Kandip.
Sir, screen is not visible.
Yes, actually, in our college, actually, electricity went out, and that's why the internet is gone, and now it is restoring. So previously, just up to last second, you have seen the screen, right? So right now, there is actually, without looking at the screen, also you can understand, no problem, and you can hear my voice properly, right?
Yes, sir, we can hear.
Okay, so I am actually using from my mobile also. the audio, so that's why you can hear me properly. So don't worry, so it will restore, but in the meantime even without looking at the figures and all, you can understand actually. So anyhow, there was no requirement of it. So whatever we have said, that is the contact ratio, the number of teeth in contact. So the n value, how much it should be? It has to be always greater than unity, right? Unity means 1, so always it has to be 1. So sometimes if it is written, suppose n is more than 1 but less than 2, what is the meaning? The meaning will be something like this. That means if 1 is less than n, this once again less than 2. That means n is lying between 1 and 2. Then the number of teeth in contact at any time, okay, at any instant, will not be less than 1 because it is greater than 1, n is greater than 1, okay, and it is never more than 2. That will be the meaning of this kind of written. Okay, if I write like suppose 1 less than n less than 2, that is the meaning. That means n is greater than 1, okay, that means it will never be less than 1. Greater than 1 means never be less than, okay, and it is less than 2 means it will never be more than 2. So within that range, that means the contact ratio is there. Yes, that is the meaning. So now if that kind of meaning is there, then we can have any number of numbers, suppose 1.1, 1.2, 1.56, whatever. So all of them are like laying in that particular within the range of suppose 1 to 2, right? So suppose if sometimes it is written like suppose n you have obtained as suppose 1.5 or 1.4, suppose, okay, n is equal to 1.4, then what is the meaning? So the meaning will be something like this. If I write like n equal to 1.4 that you have obtained, so meaning is one pair of teeth are always in contact. Okay, 1.4 meaning is one pair of the teeth are always in contact, whereas two pairs of teeth are in contact for 40% of the time. 1.4. So one pair is always there. It is always in contact. And zero point 0.4, what does it mean? So it is 1.4 is a value within 1 to 2, right? So 1.4, if it is something like this. So as we know that the pairs, if we say about the number of teeth which are in contact, it cannot be like 1.4 or that kind of thing, right? So the number of teeth, etc., it goes on like 1, 2, 3, 4, that kind of discrete numbers. Okay, it can, number of teeth cannot be kind of fraction, but n value we can get in fraction, suppose 1.4, 1.5, or whatever. So what is the meaning? Meaning will be for within that time when it is both of all the teeth are engaged and all, okay, so during that time, if it is suppose value is suppose 1.5, is always in contact, 100% of time in contact. Understood? Is it clear now? Okay, internet has restored. I'm sharing my screen once again. I think it's now visible, right? Okay, so this is basically about
Yes,
the
sir,
contact
visible.
ratio. Okay, thank you. So now we'll be talking about interference in involute gears. So what is this interference? We must know. Now, as we have said that we have all those, we can have conjugate teeth, which means that any one teeth profile you can choose arbitrarily, the other teeth profile you can design as so as to satisfy the law of gearing. So that is kind of the conjugate teeth. So that we can have. Apart from that, we can have standard teeth profile like the cycloidal teeth profile, involute teeth profile, etc. There we have said that generally we like we prefer the involute tooth profile, right? So now that is the preference. But still, once again, like with respect to, even though we are saying that involuted profile because it is easy to manufacture, etc., etc. Okay, standardization is easy. We are going for it. Okay, that is the involuted profile. But there is sometimes is a problem which is known as the interference in case of involute gears, which we must know. So what is this interference? Okay, so now see, from our previous knowledge, we already know, like we already have this expression. Okay, so we can have suppose if it is pitch circle radius is suppose r, okay, addendum circle radius, how we can obtain? We can have the module plus the pitch circle radius. Okay, so similarly the addendum circle radius can be obtained like r minus the pitch circle radius minus 1.157 times the module. base circle radius can be obtained like r of cos phi. Phi is the pressure angle, where m is the module. Also about module, we already know m equal to d by t, or from there we can obtain r is nothing but d by 2, half of diameter is a radius, or you can write mt by 2. So from here, because m is module is d by 2. So now see, from this actually different values and on different expression, actually we can have the all those design parameters, and you can find out, suppose for a particular gear and all, for a particular size of the gear, how many teeth will be there. So those things can be obtained from this particular knowledge. Okay, now this the relative, as you know, we already have the addendum circle here. Suppose the addendum circle, we have the base circle, we know about all those addendum circle and all those things has already been have already been defined. Now the relative position of the addendum and base circles, whether addendum circle is above the base circle or it is below the base circle and all, it actually depends on some factors like the number of teeth, what is the pressure angle, what is the module of a particular gear teeth. Okay, so these are some of the parameters on which actually the relative position between the addendum circle and base circle, they actually it is there. Okay, now what is this particular, as we are saying that interference is a problem which sometimes involute gears. Okay, so and why we are saying about all those base circle, addendum circle, etc. Okay, now what happens, so if a gear it has got a very small number of teeth, ultimately it also gives you the indication about the size of it also. Okay, so in that particular case, whenever the gear for a gear which is having a standard, suppose module value and a standard pressure angle value, suppose constant you consider. So in that case, you see if that gear has a very small number of teeth, okay, so then the addendum circle is smaller in diameter than that of the base circle. The addendum circle is smaller than smaller in diameter in base circle means the addendum circle, just like in the first figure, you could see the addendum circle will lie below the base circle, right? And now because of that there is a problem. So what is that particular problem? Actually what happens if you're talking about the involute teeth profile, so this involute teeth profile, they exist from the base circle to the addendum circle. Okay, and wherever actually, and at the point where the involute curve it starts from the base circle, it is the curve is tangential to the radius of the base circle. Now if the addendum of the meeting gear means the other gear which is coming in contact with this particular gear. Okay, so if the addendum of the meeting gear it is more than the limiting value, actually it is going to interfere with the addendum of the pinion. Okay, so suppose if you look at this particular figure, so if suppose the addendum circle is having a very small number of teeth, okay, and because if it is suppose the addendum circle for this gear, here is the addendum circle, okay, so actually if the if the from the addendum circle process the limiting value, we can see in this portion actually it is interfering. Okay, so it is interfering with the addendum of the pinion, right? So actually it is here, you can see it is interfering with the addendum of the pinion, and as if it is digging out, it is digging out some portion of this particular teeth. And okay, so in that particular case what will happen, so because of that the tip of the tooth on the gear, it will actually undercut the tooth on the mating pinion at this root portion. Okay, and because if it is cutting some portion from this root portion, it is okay, that is the removal of material that is happening here, because previously the addendum circle from the middle gear, it is exceeding the value and it is digging here. Okay, it is digging here, so it will undercut. Okay, so the tip of the tooth in the gear, it will undercut the tooth on the mating pinion at this particular root portion and remove some of the part of the involute profile from the tooth of the wheel. And this particular phenomenon is known as undercutting or the interference problem. And this is a problem. Okay, sometimes this is a problem if you don't properly design the gears. Okay, and sometimes with respect to the gears which has got very small number of teeth, okay, then it is evident. Okay, in that particular case the addendum circle it falls below the base circle below. Okay, so in that cases sometimes this kind of problem it can happen. Okay, understood? So this undercutting and interference is a kind of problem. So here similar kind of thing is being written here. So meeting of two non-conjugate and non-involute teeth, it is known as the interference, because the two teeth they do not slide properly, and thus very rough action and sometimes binding between the two gears, that is something welding kind of thing, okay, because of the very high level of friction generated, so some binding it may occur. And like owing to non-invalid profile, the because already the invalid profile has been broken because of the undercutting and now it is not invalid profile. So owing to this non-invalid profile, the contacting teeth, they have different velocities which can lock the two gears. So even because of this particular type of interference and undercut problem, even some it may jam even, okay. And what happens during that particular interference, the tip of the pinion, it tries to dig out the flank portion of the tooth, okay, or the root portion of the gear wheel, okay. And if some portion of the metal is being removed from the tooth portion, so because of that what will happen, definitely the tooth is going to be weakened, okay. So the tooth is weakened by the removal of the material from its root portion, okay. So now, but after that, no interference will occur if the gear messes with the undercut portion. Okay, so undercutting, if it has already happened and all, okay, if it messes with that, then once again there will not be any interference. So now we have seen that it's a problem, that means interference in case of invalid profile. So we should be able to minimize it, or you can say we have to avoid interference ultimately. And some of the methods which you can do, which you can adopt so as to avoid interference in case of your invalid teeth is invalid profile is, sometimes you can, if you as we are saying that we are talking about like make the pressure angle, we have discussed about the modules and all, okay, and the number of teeth, etc. Okay, so they are the different parameters which are responsible, and based on that actually the relative position of the base circle and the dead end circle is there. So by increasing the pressure angle somewhat, okay, you can decrease the, or you can avoid interference. So that is one way of avoiding interference. Similarly, the height of the tooth, it may be reduced, because we have seen that whenever the addendum circle it interferes there, so basically in that case only the interference or this particular type of problem we occur. So if the height of the tooth, if you look at this particular figure, so if the height of the tooth, suppose it is reduced here, so this particular day it will not interfere here, so already it will be less. So height of the tooth, if it is somewhat reduced, then also you can avoid interference, okay. So once again, another part is the addendum circles of the meeting gears, they should be adjusted in such a way that they must intersect the common tangent to the base circles between the points of tendency. That is another way. That means by carefully designing it so that it always okay. Root portion, and once the deform, and going to deform, sometimes it may develop there, it propagate, break the, it may even break the teeth also. And if the teeth is broken, it's a kind of failure, okay. Or if the teeth gets deformed also, then also it's a kind of failure, the drive will not work as desired, okay. Understood? Let me know.
Yes, sir.
Okay, thank you. So now that means if you're actually we are saying that whenever the number of teeth is very small, ultimately the sizes etc. also are there. So whenever the number of teeth is very small, okay, the addendum circle, like and the addendum circle, that relative position gets this kind of problem. Okay, so that means we have to have a minimum number of teeth so as to avoid interference, because we have seen that when the interference problem arises, when the gear has got very small number of teeth. That means there is a minimum number of teeth which should be there in a particular pair of machine gears so as to avoid interference. Yes. And now how to get them, how to find them. So for that we already have some standard expressions, so I have listed them here, so we can go through them. And these expressions will be while solving problems, once or twice if you utilize this expression, it will be, you will be able to very easily remember them. But still once again I am just going through it. So what are the terminologies that we have already discussed? So gear ratio already we have discussed. It is nothing but the number of teeth on gear to the number of teeth on pinion. So it is written generally denoted by capital G. It can be written as T by capital T by small t. Also, we already know module is D by 2. So from here we can have the radius. So all those radius values, actually we are talking about the pitch circle, the circle radius only. Okay. So the capital letters, these are for the gear, that is the bigger wheel. Small letters, these are for the pinion, that is the smaller wheel we are talking about. Okay. So for both of them, so for the minimum number of teeth which should be there in the gear as well as in the pinion, the bigger wheel as well as smaller wheel, actually the expressions are similar only. Okay. Somewhat similar. Okay. Somewhat similar only. And utilization of this particular, suppose G, etc., it is there. So for gear, how we can get? So there is always a maximum value of addendum. So what is that addendum portion? So radially, addendum was the outer portion. Radially, in the from the pitch circle to the tip portion of this particular tip. That was the addendum. So it is the radial distance. Similarly, we have dedendum. Okay, that is the lower portion. So addendum is required because we have seen that addendum is responsible, which is coming into picture during the interference problem. And all. So addendum, how we can get the maximum value of addendum? So AW max. A capital A we are using for A is for addendum. W we are using for wheel to represent the gear. Okay, max mean maximum value. So it can be you can obtain by this expression, mt by 2 whole into that root over 1 plus 1 by z plus sorry 1 plus z plus whole into 1 plus z plus 2 into sine square phi minus 1. Okay, so this once or twice if you utilize this expression, you will be it will be easy to remember. So here what is addendum? Addendum is nothing but we can get addendum with reference to the module value, which is generally known. We can get addendum value by multiplying module by some coefficient, addendum coefficient. So AW into M. Okay, so we can get like that. So in that case, the minimum number of teeth on wheel we can get by this expression. T is equal to 2 whole into A of AW. AW is nothing but addendum coefficient on for this particular wheel only we are talking about right now. Okay, so this standard expression we have. Similarly for pinion also, similarly we can get the addendum value. Okay, and from there we can get the minimum number of teeth which will be required so as to avoid interference. Okay, and once again here also in case of pinion also addendum we can get by the addendum coefficient for opinion multiplying addendum coefficient from opinion with each module. Okay, so that is how we can get the addendum. Sometimes this AP, that is that coefficient, its value itself is equal to sometimes 1. Okay, and then your addendum value for this particular wheel or the opinion, it itself becomes equal to the module. Okay, so in many cases you will see like that addendum coefficient of the value check this question is being recall this. So like degree 25 nowadays are the standard expression of value for your pressure angle. Previously 14.5 degree it was also utilized. Nowadays also you will come across 14.5 degree in some of the older generation now, but nowadays we have come up like to 20 degree 25 degree and so. Okay, and why it is happening? Because in one of the method to avoid interference itself we have seen that if we can somehow increase the your pressure angle value, then also there is a tendency of we can go for limiting the interference or we can somehow avoid the interference. So 20 degree pressure angle they have become nowadays common. Okay, so now whenever two wheels which are of equal size and they have got 20 degree pressure angle and its addendum itself is equal to the module value, in that particular case the minimum number of teeth on both the wheels it has to be 13. So 13 is the minimum number of teeth so as to avoid interference. So this is this is true for two wheels which are of equal size and 20 degree pressure angle and the addendum value itself is equal to the module. Okay, understood?
Yes, sir.
Okay, thank you. So the very small last topic that we'll discuss, already I have told you to take this as an assignment, but still we are somewhat discussing in brief about the interchangeability of gear. So now whenever the uh, gears they are sometimes standard, so then it becomes interchangeable. That means you can change with another. Suppose one is worn out and all, then what are the parameters like that you have to look at so as to replace it. Okay, then it so as to get the replacement, or ultimately that is nothing but the interchangeability. Okay, so now if you're talking of gears of using gears of standard dimensions and all, now during the gradual with the passage of time, when there is gradual wear and tear, or sometimes if there is something happened to the gears and all, and the gears has failed or it has worn out, then there will be requirement of replacing it, right? You cannot like keep on working with the worn out gear drive, so you have to replace the wheel, okay, or that teeth you have to replace. And in that particular case, the another gear that you are going to buy or you are going to manufacture, it has to be interchangeable with the previous case. Yes. And now what are the parameters, what are the on which the factors on which basically the interchangeability of gears they are it depends. Okay, so if that gear it has to be interchangeable, okay, then it has to specify certain specification. Okay, so and it has to fulfill them. Now suppose if you are an engineer in a particular plant and all, and some machinery it has collapsed, and some like suppose some gears has it has got worn out, or maybe it has broken, some teeth has broken, or it has developed crack, or whatever be the method of failure. So if your it will be your duty to suppose diagnose that problem, and you have to find out the solution. And suppose you have found out the solutions problem that you have actually a gear has failed and you need to replace it. Okay, so now you have to tell something, right? You have to tell something to the vendors, some specification you have to give to the vendors and all. Okay, so as to so that you can get a gear which will be interchangeable. If you otherwise get a particular gear which cannot be utilized there with the in that particular situation, okay, it is not going to match and all that kind of problem it may be there. So in that case, the factors that you must know when the gears will be interchangeable. So the if a gear it has to be interchangeable, then what are the factors it should fulfill? So they should have the same module, and the pressure angle it should be same. Okay, and the addendum value and the addendum value it has to be same, as well as the thickness has to be same. Then only effectively you can interchange a gear with another. Okay, so like these are the kind of about the factors which basically govern the interchangeability of gear. Okay, and why we're always talking about standard gears? Okay, why we are saying that you should go for standards and all, standardization is always important, and all those things. So actually the manufacturing of gears of if you follow the standard system of gears which you will be coming across in your machine design also. Okay, so the standard if you follow the standard system, then actually even the manufacturing of the gears also it becomes very easy, because we already have the standard cutters etc which are already available for proper manufacturing of the gears. Okay, so you don't have to go for, suppose if you go for standard unit standard system, okay, standard cutters etc, then you don't have to go for different societies are having different manufacturing system. Okay, so in different societies it's standard, and even apart from perspective of the gears also easy, because we already have the standard cutters etc, all the setups are already available for manufacturing the standard gears. But if you go for, suppose sometimes the requirement maybe some other interchangeable gears, or conjugate pair of teeth you might have to develop. So in that case also it is possible, but the thing is you have to go for specialized manufacturing method which may be more costly and all. Okay, so with this basically we'll stop today's topic here. So in the next class we'll be discussing about the gear trains. So if you have any question, any doubt, you can ask me, or if you have understood you can let me know. We'll stop here today. If you have any doubt you can ask.
No doubt, sir.
Okay, thank you. So if you have understood, that means you have understood. No doubt means you have understood, right? I can safely assume you have understood. So
Yes,
others,
sir.
what about others? Okay, so I hope all of you have understood. So go through this. I'll be providing them also. Okay, so we'll stop here. So thank you everyone for attending.